All right, so today I want to talk about some misconceptions about geology. I'm going to do the thing that I like to do, which is walk in the woods. So misconception number one is that plate tectonics is floating on top of molten lava. And that's actually wrong. So I'm going to do a little diagram to how do we know that? How do we know that? Yeah, we know that because of the work in seismology. So, surface of the earth. Boom. Let's do a little tree. And a little person. And a house. I'm not getting any points for being an artist. Anyway, the conventional model, you get the surface of the earth, and let's say you got a plate. It splits there. The conventional model is that you've got hot magma coming up, and then when it gets to the surface, you get one coming up this way, and then, so in this case, you get and this is the mantle convection. So that's what I was taught when I was in grade school. That why do the plates move? Because we've got mantle convection going on under here, and then because the mantle underneath is moving this way and this way here, these plates are slowly splitting apart. And the longer you wait, the more this splits apart. And in the case of, we got a spreading ridge here. So in this case, like it would be Iceland, and then you get a little volcano here and lava kind of covering the earth. That's kind of the model that's taught, even still today, to kids. And it's actually wrong. So I'm going to draw a plate here again. And in this case, I'm going to make the ocean here. There. We'll put a little boat here. And then at the bottom of the ocean, we're going to have another plate. Now, at a continent edge, so this continental, or this is oceanic plate, and it's subducting. And at a subduction zone, so I'm actually going to get a couple of misconceptions out here all at the same time here. So at a subduction zone, they often teach that this thing here, the subducting plate, is melting, and that's what causes volcanoes. So I'm going to draw a little volcano here. It is true that volcanoes do form at subduction zones, but what is actually happening, so the bottom of the ocean, some of this plate is becoming some of this water is becoming a part of the plate, and then when it gets down nice and low here into this lower area, it gets to a certain depth, and then it releases this water. So there is convection going on. I'm not going to say that there isn't convection going on. There is convection going on. So once you get down into this area and the rock is hot, this blue stuff is actually starting to, so this, as I mentioned before, this area right here is actually solid rock, but once this material here gets down in here, it actually starts melting. So there is melting happening here, but it's not the melting of this plate. This plate has stuff in it that is causing the melting to happen. And then this bubbles up, and then you get a volcano. So what is it that's driving this subduction? It's this thing called slab pull. It's not this mantle that's circulating, that's pulling this plate. It's actually the weight of this. So this is one giant slab of rock, and it is pulling down, and it is very, very heavy. Just imagine like mountains and mountains and mountains just sinking down into the earth, and like a conveyor belt, it's pulling the rest of this plate along with it. And then it's sucking the rest of it. And that's what drives plate tectonics. It's this slab pull. Slab pull is responsible for plate tectonics. Got it? Got it? If anybody ever tells you it's mantle convection, fucking send them my way. Because they're wrong. They've been teaching that in school. They're still teaching that in schools. I don't get it. It's such an easy concept. This thing's heavy, it pulls down. That's what causes it. It's not mantle convection, I think. So, another thing that's kind of neat is, so I'm just going to draw the Earth. I don't know if you can read that. Anyway, let's just say there's an earthquake that happens right there. But, you know, when the earthquake happens and it's sending these shock waves out, they happen on the surface, but they go through the crust. So they get sent off in all directions. Now the cool thing that I kind of learned about is that they don't just go in straight lines. They actually curve. And as they're going down there and they're curving, as I mentioned earlier, because the pressures are so high down here, these waves are actually traveling faster than these ones. So this blue wave, we'll pretend that this is a seismic station. This blue wave will send a, let's just say this is like an earthquake meter. So this blue wave will arrive first, and then shortly thereafter, you'll get the red. So at this spot here, it's going to be the blue that arrives first, and then the red. And the reason the blue arrives first is because it is denser down here and it travels faster. Now, why does it curve, you might ask? I got a kind of quick little drawing that I can do for that, because that's actually super cool. If you've ever seen like a prism, or let's just use a piece of glass. So as light enters different surfaces, so light's going to be coming along here, it hits this, and then it's going to change direction. It's going to travel down this way, and then as it exits, it's going to travel in the same direction that it was going before. And the same thing kind of happens with, let's just look at the Earth as different layers. So, and in this case, we'll use an earthquake. And heck, let's use green. So get your little earthquake happening here, and it sends a wave here. Now this layer is more dense than this one, and it sends it down this way. And then when it gets to this layer is more dense than this one. And then when it gets to this one, but because the layer progressively gets more and more dense, it's not layers by layers, it just does this curve as it goes down into the earth, and then eventually it makes its way back up. It's pretty cool. Anyway, that's a few things about geology that I've learned over the past few years, some misconceptions. And if you actually think about it, it's not that difficult and it's super interesting. So anyway, thanks for joining me on my walk in the woods. I'll talk to you later. Ciao.